The 1811 to 1812 New Madrid sequence consisted of 3 large earthquakes. Magnitude 7.5 on December 16, 1811. Magnitude 7.3 on January 23, 1812. Magnitude 7.5 on February 7, 1812. The first earthquake was followed by 6 aftershocks in the range 5.5-6.3 in the first 2 days. Hundreds of aftershocks were felt in 1813. The geologic record of pre-1811 earthquakes reveals that the New Madrid seismic zone has repeatedly produced sequences of major earthquakes, including several of magnitude 7 to 8, over the past 4,500 years. The earthquake ground shaking was not limited to the principal main shocks, as there is evidence for a fairly robust aftershock sequence. In total, Otto Nutley, an earthquake expert and professor of geophysics at St. Louis University, reported more than 200 moderate to large aftershocks in the New Madrid region between December 16, 1811, and March 15, 1812. 10 of these were greater than about 6.0. About 100 were between magnitude 5.0 and 5.9, and 89 were in the magnitude 4 range. Nutley also noted that about 1,800 earthquakes of about magnitude 3 to 4 during the same period. 1811, December 16th, the first main shock. This powerful earthquake was felt widely over the entire eastern United States. People were awakened by the shaking in New York City, Washington, D.C., and Charleston, South Carolina. Perceptible ground shaking was in the range of 1 to 3 minutes depending upon the observer's location. The ground motions were described as most alarming and frightening in places like Nashville and Louisville. Reports also describe houses and other structures being severely shaken with many chimneys knocked down. In the epicentral area, the ground surface was described as in great convulsion with sand and water ejected tens of feet into the air. 1811, December 16th, the dawn aftershock. This shock followed the first earthquake by 6 hours and was similar in intensity. A large event felt on the East Coast that is sometimes regarded as the fourth principal earthquake of the 1811 to 1812 sequence. The event is described as severe at New Bourbon, Missouri, and was as terrible, but not equal to the first. 1812, January 23, New Madrid, Missouri. The second principal shock of the sequence. It is difficult to assign intensities to the principal shocks that occurred after 1811 because many of the published accounts describe the cumulative effects of all the earthquakes, and because the Ohio River was iced over, so there was little river traffic and fewer human observers. Using the December 16th earthquake as a standard, however, there is a general consensus that this earthquake was the smallest of the 3 principals. 1812, February 7th, New Madrid, Missouri. The third principal earthquake of the 1811 to 1812 series. Several destructive shocks occurred on February 7th, the last of which equaled or surpassed the magnitude of any previous event. The town of New Madrid was destroyed. At St. Louis, many houses were damaged severely and their chimneys were thrown down. The mesoseismal area was characterized by general ground warping, ejections, fissuring, severe landslides, and caving of stream banks. The first earthquake of December 16, 1811 caused only slight damage to man-made structures, mainly because of the sparse population in the epicentral area. The extent of the area that experienced damaging earth motion, which produced modified Mercalli intensity greater than or equal to 7, is estimated to be 600,000 square kilometers. However, shaking strong enough to alarm the general population, intensity greater than or equal to 5, occurred over an area of 2.5 million square kilometers. The earthquakes caused the ground to rise and fall, bending the trees until their branches intertwined and opening deep cracks in the ground. Deep-seated landslides occurred along the steeper bluffs and hillsides. large areas of land were uplifted permanently, and still larger areas sank and were covered with water that erupted through fissures or craterlets. Huge waves on the Mississippi River overwhelmed many boats and washed others high onto the shore. High banks caved and collapsed into the river. Sandbars and points of islands gave way. Whole islands disappeared. The region most seriously affected was characterized by raised or sunken lands, fissures, sinks, sand blows, and large landslides that covered an area of 78,000 to 129,000 square kilometers, extending from Cairo, Illinois, to Memphis, Tennessee, and from Crowley's Ridge in northeastern Arkansas to Chickasaw Bluffs, Tennessee. Geology provides context for understanding the 1811 to 1812 New Madrid earthquakes. It is well known that earthquakes occur as a result of slip-on faults. Furthermore, strong ground shaking and fault slip leave a permanent record in the geology if the conditions are favorable for preservation. Geologic data show that several faults in the region have slipped and deformed the NMSZ ground surface, in some areas lifting it up, for example, Lake County uplift, or lowering it, Reelfoot Lake, relative to surroundings, thus affecting flow of the Mississippi River. For example, the Reelfoot Scarp is a 10-meter high hill formed by at least 3 major earthquakes on the Reelfoot Fault in the last 2,400 years. The predominant style of recent faulting in the New Madrid region is strike-slip faulting with horizontal movement nearly parallel to the course of the Mississippi River. The conditions within the Mississippi River Valley are not favorable for preserving evidence of active strike-slip faulting. Despite these unfavorable conditions, there is good evidence that several northeast-trending faults in the region are active and have generated significant earthquakes in the past. Over the last 20,000 years, the Mississippi River has entrenched and removed sediments that overlie the ancient Rift Valley, potentially erasing some records of faulting. However, geologic investigations show that several ancient faults with low long-term slip rates within the New Madrid seismic zone have been reactivated and show evidence of recent movement. Any of these faults could potentially generate an earthquake under the right conditions, for example, a favorably oriented stress field and enough accumulated strain. Thus, from a geological perspective, the New Madrid seismic zone region has the necessary ingredients for the occurrence of future earthquakes because there are a number of faults with evidence of past slip, as well as evidence of multiple episodes of strong ground shaking in the form of liquefaction features, and new evidence of broken stalactites and caves that show a history of repeated earthquakes. In the 21st century, earth scientists, federal and state officials, as well as municipal officials located within the NMSZ have shown a great deal of interest in mitigating the potential effects of damage associated with future large earthquakes in the region. All parties are aware that modern cities and towns in the NMSZ have substantially larger human populations than during the early 19th century. And they agree that the occurrence of major earthquakes in the region comparable to those of the 1811 and 1812 earthquake sequence would produce tremendous loss of life and billions of dollars in property damage. Consequently, earth scientists have monitored the region's ongoing seismic activity since the 1970s, and some scientists have developed probability models to determine the region's future earthquake risk.